welcome back. Welcome back. We are now on P2. Let me zoom in. P2 says explain how principles of computer programming are applied in different languages to produce software applications. So this was from the spec itself. That's the criteria I copied from the spec. This was also from the spec, but this is from that section that was labeled task 1, I believe. So it says we need to explore the features and characteristics of programming languages to explain the use of different types of programming languages, what particular problems each programming language discussed can be used to solve, given a comparison of those programming languages. So in short, you're going to compare different programming languages. Now, I would stick to about 3, 4, or 5. 5 or 4 seems like a better number, so we have more things to compare. This will be a very, very long section, and here I have the spec link, but I already have the spec open. I think this is going to be a combination of parts or sections A3 and section A4 at the same time. So before we start doing anything again, we're going to break down the problem. So before we can speak about the principles of computer program, we have to first understand what is computer programming. So that's why I have this first question here. I'm going to try and share an empty document. Well, not an empty document, but a document with not as many comments, but simply with questions that you need to answer to fill in so that you can have a fully flushed out paragraph for P2 or a couple of paragraphs for P2. I don't have it yet. I'm going to put it on the website as soon as I'm able to get the website up and running and put content on there. Next, we have what are the principles of computer programming. Now, when I Googled this myself, there is no one list that fits all. Here, actually, this first one, when I Googled what are the principles of computer programming, this first list I got here was a pretty decent list with 10 items on there. So you could use this one, or you could scroll down and use any other list. Some of them have 5, some have 10. This one has 7. I like this one because I'm lazy. I'm going to choose the first one, and the list is here. If you click onto the website, you will see the full list of 10. Mention each one, right? So if you go for one with 5, obviously that's less stuff for you to write about. So reference the website number 1, and you speak about each of those things, but do not copy and paste. And also don't just use one website. If you find a website with 10, find one with 5, and find one with 7. If you can combine things and combine them, that's perfectly fine. But make sure you reference all 3 websites. So I'm going to do something like this, right? If I have my document, let's say I copy the first 5 or 6 there. I'm going to come here. What are the principles of computer programming? You're going to have a list, a decent sized list of what you think the principles are. This is not an exhaustive list. This is simply the first, 5 I copied from that other website. Speak about each of these. So you've listed them now. You've stated what they are. Now you come and speak about them. So KISS, and then you give a mini paragraph on what is keep it simple stupid. Write dry code, you give one on that as well. So write dry code. Next one is open, closed. Next one is composition over inheritance. All right, speak about what each of these terms mean. Give a decent paragraph, and that's that section completed. What are the principles of computer programming? You're finished with that now. Give about 5 of them and you're good to go. Now, the next stage, I think, is actually not the programming languages themselves again. You're going to give a brief introduction on the different types of programming languages. And I copied this from the spec. I cheated, right? You're allowed to copy stuff from the spec. You're allowed to use the spec as not only guidance, but you're allowed to take speaking points directly from the spec. So when I go back to the spec, this is what A3 looks like on the spec. And here I have procedural. So this is a procedural so these are procedural programming languages. Now, most of these are general purpose. They can solve more than one problem, but typically we use these for procedural. We use these for object orientation. We use these for event driven. It doesn't really matter. Speak about each of these, what they are. So for procedural, I'm going to say, what is it and its main purpose? You could join that question into one thing, to be fair. What is a procedural programming languages, or what are procedural programming languages and what are their main purposes? Why do people use procedural programming languages? So maybe I'll add that on the end as well. Why use it? If we have procedural, we have object oriented. Why would we use procedural over the others? Why use it, right? Why use it? So why do we use procedural programming languages if we already have object oriented, we already have event driven, machine and markup? Why is this one important? So let me copy this and paste it on the below ones as well, because that's quite a decent one to have for each one. And you're going to go through and answer this for each one. Again, you're going to give it its own heading. You're going to say something along the lines of the types of programming languages are procedural, object-oriented, event-driven, machine, and markup. There are more, but these are the main ones that we should focus on because, again, I copied this from the spec, so we're cheating by copying from the spec, but that's fine because that's what the spec is there, for us to learn from the spec. So after I've copied or stated these types, I'm going to go in and give a mini paragraph, again, a couple sentences just to make sure I understand what a procedural programming language is, what's its main purpose, so obviously why people use it. Any which way you want to word that, that's perfectly fine. And that's it, you're done. Do this again. This is going to be a paragraph each. So procedural, give it its own mini paragraph, object-oriented, its own mini paragraph, so on and so forth. Now, the final stage of P2 is what I think is going to be quite tricky for some people. So it says compare some programming languages. I would do about 4 or 5. Better yet, steal the ones from the spec. Again, I'm stealing directly from the spec. And I go back to the spec. And under procedural, we have C, Perl, Python. Object-oriented, we have C++, C Sharp, and Java. Event-driven, we have Visual Basic. Machine, we have Assembler. Markup, we have HTML. Steal any 5 you want from here. That's perfectly fine. I would probably do 1 from each category, or maybe 1 or 2 from each category, so that we have a decent list of different types of programming languages. So for example, I created a list down here of the ones that I might want to use, and I said Python, C++, C, Kotlin or Java, and R. Before you start your comparison, give people some information on the thing you're going to be comparing. And what I've done, I've said Python is a high-level general-purpose programming language which has risen in popularity due to its easy-to-understand nature, which allows for fast prototyping. Give more information. That's why I have give more there. This was just a random sentence or two that I had in my head, which I could put on paper quickly. You go and use a website, find more. Let me put reference it. Make sure that any information you find, you reference. I've shown you guys how to reference already. Go back and reference it. These are just some common speaking points that you can mention about the language. Not exhaustive, but decent enough that you can have a better understanding and give a decent introduction of the language itself. So you can speak about the variables in Python, local, global, constant, and whatever points you choose to speak on, I would recommend that you speak about those same points for every language. So for example, here, again, this was copied from the spec. So if I delete this quickly, for Python, I've said variables in Python, local, global, and constants, data types in Python, and data structures in Python. I've gone to C++ and done exactly the same thing because this is going to be building up to our comparison. So we're speaking about variables in Python. We're also speaking about variables in C++, speaking about variables in C, speaking about variables in Kotlin, and speaking about variables in R. So that when it comes to compare, we have quite a bit of information to compare, and make sure you reference the websites you get this information from. None of it is yours. So speak about variables in Python. They're going to be something along the lines of variables in Python are statically or dynamically typed. Constants are created by simply making the name of the thing. So for example, in Python, if you do name equals Bob, right? Let me just make that lowercase, sorry. Name equals Bob. That's a variable. If I do name equals Bob, this is a constant. This is a value that cannot be changed, whereas this one can. And in Python, that's simply done by making it uppercase, right? In C, it's going to be a different way. I think it's const, C-O-N-S-T in C or C++, I think it was. But I don't know all the information straight off the top of my head, but that's where the research comes in. You guys need to go and find this information. Don't stick with the points I've chosen. So if I undo some of this, let me just go back to my list I deleted earlier. If I undo some of it and come back to my list, choose stuff that you want to speak about. It could be command words. For example, in Python, the word print is a sacred word to Python, a command word to Python. So I cannot just randomly use the word print when writing a program. I have to use a different name, a different variable name. Another one I know I can't use is maybe double. I'm not allowed to use the word double in Python because that's a word that Python has secured for itself. We've been over constants, data type, statements. You choose whatever you want to choose, but you're going to have to go through and look at how that thing is actually used. Another easy one that I didn't add on my list that some of you guys might want to add, logical operators. Is it equal to, greater than, less than, whatever? The comparison operators, I call them, right? This is a logical operator, it says here, but the comparison operator. So in GCSE maths, when you did less than, greater than or equal to, less than or equal to, not equal to, opposite, whatever the case is, use that. Every single language in the world, every programming language has to have a logical operators, because we're constantly comparing things in programming. Is this higher than that? Is this lower than that? Is this equal to that? We're always doing that. So that's a good one there. Hopefully that part makes sense. But pause and read over it again, and it's in the spec. So use this as just a speaking point, right? And again, whichever ones you choose, make sure you choose the same speaking points for each programming language. You don't have to go through every single one, but if you do, well done. Very well done, because that's a lot of typing, that's a lot of research. It's pretty easy, to be fair. It's just going to be a lot of work. So if you have the time, do it. If you don't have the time, I would choose about 3 or 4 to speak about. So again, for Python, I have variables, data types, and data structures. For C++, I've got variables, data types, and data structures. For C, same thing, variables, data types, and data structures. I think choose about 3 or 4, speak about those 3 or 4. Now, finally, we have the comparison section. Now, this part up here, which I mentioned, the variables and data types and data structures, that was a mini comparison as well, because these are done differently in each language. But down here is where we have the real comparison. And the reason I say this, so people in the UK who have internet, right? When you're looking for a decent internet deal, most of us Google something along the lines of best internet deal, right? Let's say best internet deal. You press enter, you probably go to, let's say, Money Supermarket is always a good website. I'm going to go to that one there. And when we're comparing deals or comparing mobile phone contracts, comparing internet, we typically go to a website like this where we can have similar kinds of things being compared from different service providers. So this is Vodafone as the first one. Next, we have Virgin, then we have Virgin again, then we have BT, then we have Vodafone again, then we have No Broadband. But the things that they're comparing, same things. We have speed here, speed here, speed here, the amount of downloads, the setup cost, how long the contract is going to be, how much is going to be roughly per month, and if you get a voucher or not. So we're going to do something very similar in, where's my Word document? Here. So this list here, I got from the spec. I stole it directly from the spec. And again, that's perfectly fine. So when I go back to my spec and I go to A3, it says factors to compare and contrast in programming languages, including, and it tells us exactly what we should compare. You don't have to use everything there, but these are the ones that I will use. I think I left off only one of them. So hardware and software needed for running and developing a program. This is the specs, the specifications to run that software on a laptop. And the hardware that laptop must have to run the software. So if I Google Python specs, let's see if I can find this information quickly. I'm not going to cut this part out. Here we go. Perfect. So these are the specifications, the hardware and software specification I need for Python. So let me click on this and see if I can get some more detail and try and explain what this means. All right, here we go. Let me zoom in. So it says modern operating system, Windows 7, Windows 10, Windows 11 does work as well because I have Windows 11 on here. I'm going to skip the rest of them because if you have a Mac OS laptop or a Linux laptop, it's more or less the same thing, right? We have x86, 64-bit Intel or AMD architecture. So if your processor is a 64-bit processor as of Python 3.11 or whatever it is now, right? We need to have 4 gigabytes of RAM, so random access memory on our PC that holds the temporary instructions for us. And then we have 5 gigabytes of free space. That's a bit much, but this is the hardware and software needed. So what I might do, let me just copy this in. Actually, let me just take the stuff I need. So I know I'm going to need Windows 7, 10, or 11. I'm going to need 4 gigabytes of RAM. So for Python, I know I'm going to need Win 7, 10, or 11. I'm going to need, what did I say again? 4 gigabytes of RAM. And careful with the GB, right? Gigabytes is the capital GB. And let me just put this one next to it. Gigabits is the capital G, but the lowercase b. All right. So that's just a thing there for you guys to note. I think it said 5 gigabytes of storage. Storage and RAM are different. Storage is where you save your files, where you save your Word document, where you save your Python file, where you save your images. RAM, the CPU uses RAM to hold instructions that it needs, right? And then let me go back to my website again, which is here. I'm going to need, it says x86 64-bit CPU. All right, so any CPU will most likely work. So I'm just going to put x64 CPU, Intel or AMD. This is what it needs. This is all it means. And you go and do exactly the same thing for R, for Kotlin, for C++, for C, for Java, for whatever you want. Now, performance. Let me go back to my list again, actually. Special devices required. This is the one I left out because really and truly, there are no special devices required for programming nowadays. The only thing you really need is just a laptop, like I mentioned before, just the specs from that laptop, and you're going to need a mouse and keyboard. That's it, really. So I would leave that one out. But if you can think of some, where is it again? Sorry. If you can think of some special devices that are required, by all means, put it. Performance. When it says performance, it doesn't mean performance of your laptop. What it means is the general performance of that programming language. So if I go on Google uh, performance, oh, I already did it earlier. Here we go. Performance of programming languages. I'm going to go down to, I think this was a decent list. I can tell you straight away, C is always going to be at the top. C, C++, C Sharp is always at the top. Python, as popular as Python is, it's never ever at the top unless it's Python, a C implementation of Python. C is just super fast, right? Let's just leave it at that. So here we go. C is the fastest one. So C language, then C++, then Rust. So whatever language you choose, go and research how fast that language is compared to other languages. I've chosen, luckily for me, I've chosen pretty decent languages here, pretty top tier languages, very, very popular, all of these. So I can find information on this relatively easily. So I can even Google, let's just say Python performance, right? Let's look at that. Now here it says, in this article, we'll discover that Python is not a bad language, that it is just very slow, right? It's, in my opinion, an amazing language. And with the specs of PCs we have nowadays, we don't even feel that slowdown. But if you're working on an application that needs seconds or milliseconds performance for it to do what it needs to do, then it might become a massive impact later on. What I would do, again, let me go back to my document, have my list, go to the performance of Python versus the others, right? So performance for Python might be number 4 on the list, right? And then maybe you have a key explaining why it's number 4. Fastest is going to be number 1. In my opinion, that's going to be C. Easy, easy. Second fastest is going to be C++. So whatever list or whatever measurement method you want to use to fill this table out, that's fine. But performance means how fast your language is versus others. And let me expand on this a bit more, right? When you're writing a code in Python to, let's say, print name, print hello world, right? You do print, you do hello, and you do world. This is how Python typically works. For Java or Kotlin, well, not Kotlin, but Java, old Java. So this is Python here, right? Let me put Python. And for old Java, which I used back in university, Java, the way you would do this, I don't remember exactly how it works. It would be public, static, main, void arguments, right? You have an open bracket here, you have one here, you have close here, and then down here you have a close as well. And in here you would have a public static main void argument system out print line, and then you can say hello world. As long as this is as much text as this uses, this Java is still faster than Python, which is really strange when you think about it, right? To get accurate performance of a language, we do exactly the same thing in that language as we do in every other language. So in Python, this is how I say hello world. In Java, this is how I say hello world. And when I run my Python program, this might take, let's just say for argument, 1 second. And you might think that was really quick. Why are you stressing about that? It's not about that, right? This might take 0.3 seconds. Now you'll be thinking, oh, that one's 3 times longer. Yeah, exactly. So imagine if I had a code that was thousands and thousands of lines long, and this one took 5 seconds to run the entire thousands and thousands of line worth of code. This one would take 15 seconds, right? So look at the performance of your chosen language, fill this table in with the performance, and that's it. Next, we have application area. And what this means, my interpretation of this, it simply means what applications utilize this programming language best, or what area is this programming language really excelling in. All of these are general purpose programming languages, which mean that they can solve almost any problem that you throw at them. However, I know for a fact that R was mainly, I think it was made by Google if I'm not wrong. R was made for like statistical models, AI, extracting data, and Python is used for stuff typically as well. Kotlin is going to be used for Android application development because I've used that one before. C is mainly used nowadays for embedded systems because it's super fast. And embedded systems, they're very tiny devices where the code needs to be minimal. It needs to be super fast. That's it. C++, similar to Java and Python, again, high-level programming languages that does quite a bit, but C is super quick, super quick, right? So you simply look at the main areas of use, not the only area of use, because surprisingly enough, I can use Python to make Android apps. I can use Kotlin to make Android apps. I can use C++ to make Android apps, but I have to think about the main areas of use, the main area that they're used in. Development time and simplicity. Now, I think you might be able to join these two depending on how you word it. So, development time is simply how long it takes roughly to develop something. Simplicity, how hard it is to understand something, the difficulty in using and understanding something. Python for dev time and simplicity, I think is going to be one of the highest because Python is very close to readable, very close to human readable language. For example, let me get rid of this example down here. Let me do Python again. And I could say name equals, I'm not sure if I showed this before, name equals Bob, all uppercase, right? For me to make this lowercase in Python, it is so simple. I simply have to do name dot lower, open bracket, close bracket, and that's it done. This is how I make it lowercase. And let's just say I got it as uppercase. I needed to make it uppercase. Apologies. I do name dot upper, open bracket, close bracket, done. And that's it. It's done. Right? So because of that, I think Python's development time for developing your project might be very quick because it is easy to understand. It's very simple. So that's why I'm saying you might be able to join these two. If you don't want to join them, that's perfectly fine. You could actually just go on Google Python project development time, Python project simplicity, and get some information. Again, make sure you reference it. R project development time, R project simplicity, Kotlin project development time, Kotlin project simplicity, whatever you think is best. But this is a table, or I would do a table like this. Choose different languages if you want to. That's perfectly fine. I recommend that even. No two people in the class should have the same 4, 5, 6 languages comparing because there are hundreds of programming languages. No two people should have the exact same things at the top to compare unless you copy the things you're comparing directly from the spec. That's how I would do P2. It's a bit long-winded, I know. It's a lot of information. I think P2 is probably going to be easily one of the longest sections. But hopefully that made sense. Hopefully that was clear. And good luck.